So welcome everyone to this panel on environmental forecasting for Antarctic operations. It's a pleasure to be here. I'm Daniela Liggett, based at the University of Canterbury in New Zealand. And I'm actually joined in spirit by my co-lead, Emma Stewart, who unfortunately couldn't join us in person this year. Let me advance the slides. I do need to use this beautiful device and hope it works. It does. So both of us, Emma and I, are members of PPP SARA, and you've heard quite a lot about this PPP task team that focuses on societal and economic research and applications. And you've also already seen our beautiful picture there taken in Punta Arenas in Chile at one of our workshops. Just to briefly remind you some of our key conclusions that we've explored in a number of sessions already, essentially tell us that forecasted services are not necessarily always what the users need. These two don't necessarily overlap. We've also heard that this dualism with which we've seen users and producers does not always apply anymore, and that some users are now also producing their own services to fill some of those gaps that remain. We've also heard quite a lot about the experience that is used, that the focus on experience, on personal experiences in the Arctic and Antarctic when operating and looking out of the window, that is often more important in terms of making immediate decisions and relying on extensive forecasts. So those reminders will serve to frame some of the messages that you will hear from our esteemed guests today. And today here we have with me Vicki Heinrich from the University of Tasmania. She's a PhD student there, but is also affiliated with the Bureau of Meteorology in Australia, and she's one of our newest YUP fellows. So thank you, Vicki, for joining us. And online, we've got Lisa Kelley, who's an IAATO Deputy Director, Executive Director, and also, hello, Lisa, that was just prompted that you popped up there. And she's also a Director of Operations and International Affairs with IAATO. So it's nice to have both of them here. And our guests in the next few minutes will explore some of the risks they encounter in terms of operations or their research in the Antarctic, and how operators and practitioners address those and try to reduce the risks, in the hope that if we explore those and look ahead, we can examine where we are now and hopefully in the future focus on targeting some of those remaining gaps. And with that, I'll just hand over to Vicki, and you can probably use the podium.
So, good morning, everyone. I'm Vicki Heinrich, and I'm a PhD candidate at the University of Tasmania in Australia. Before we begin, I wish to acknowledge the traditional owners of the land on which I am working and studying, and pay my respects to elders past, present, and emerging. So today I'm going to talk about some of the interview findings from my mixed methods research exploring weather-related decision-making, information use, and risk perception in Antarctica and the Subantarctic. I will focus on people's questions, responses to questions about risk. So as we know, weather plays a part in many incidents, injuries and deaths in Antarctica, the Subantarctic and Southern Ocean. People's safety can be negatively impacted by decision errors, poor risk perception and a lack of situational awareness. To help people make safe decisions, we first need to understand how and why people make the decisions they do, and the factors and pressures that then influence their cognition. This means that we need to understand people's operational and work contexts, their decision-making and risk perceptions. So a little bit of theory to start with. There's different ways of defining risk, and to respond to a hazard, people must first perceive it as a risk. According to Kaplan, a hazard is a source of danger, while risk is the probability of future damage, loss or injury. Risk perception is individual to each person and can be based on their feelings, familiarity and exposure. People's feelings, whether they're positive or negative, influence their judgments of perceived risk and benefit. So during their decision making and consequently people's behavioural responses can diverge from what more rational cognitive evaluation of the best course of action might be. Risk perception is multidimensional and there are many factors that combine to influence people's concepts of, and mental models of risk, including the severity, likelihood, immediacy of the event, self-efficacy and social and cultural factors. Therefore, risks should not be considered in isolation. Research shows to produce effective warnings and safety messages, we need to understand how people think about and respond to those risks and warnings. Otherwise, people may ignore warnings or don't interpret and respond to the information as intended by the service providers. Theories like naturalistic decision-making and situational awareness can help us understand people's decision-making processes and the influence of factors like their previous experience and operating environment. Understanding people's concepts of risk and decision-making around hazards in Antarctica can then inform our weather service improvements, training and education. So participants' experience in Antarctica ranged from a minimum of about 6 weeks to over 20 seasons, with an average of 2.5 years of deployment time. The participants worked in a variety of roles at research stations, field camps and on tourist ships at locations indicated by the red dots on the central figure. Only 42% of the participants received any training about weather from their Antarctic employer, while 74% received some form of information about the weather or an Antarctic. And 19% of people received no training nor any information about the weather and environment in Antarctica. More than half of the participants spent 50% to none of their working time in a climate-controlled building or indoors, and only 20% of the participants spent all their work time indoors, so people were outside quite a bit. When asked about risk in Antarctica, people talked about the consequences of risks, how people might be injured or hurt, and how they managed and reduced risks. A few people, often those with less Antarctic experience or seniority, didn't perceive many risks in working in Antarctica, suggesting that training and controls had removed any risk. The more experienced expeditioners stated that Antarctica was an inherently risky environment where you could reduce risk but never completely remove it. So these participants viewed risk as something to be managed. Compared to those who'd spent less time in Antarctica, experienced people and those who were responsible for others had more developed mental models and concepts around risks and safety. Reducing risk and keeping people safe was a constant part of people's planning, their decision-making processes and situational awareness. Based on their own risk and decision thresholds, organisational operating procedures or their past experience, participants used weather information, observations of environmental conditions, and to help make safety and comfort decisions and to guide decisions about when to stop activities, change their plans or return to a safe location. People had different levels of comfort, risk and danger related to weather hazards. If the conditions were too poor, like high winds or low visibility, they were viewed as dangerous and to be avoided. However, the decision threshold of it's too dangerous to proceed differed between participants based on their individual risk tolerances, priorities and perceptions. Experienced expeditioners expected weather conditions to sometimes make working outdoors uncomfortable. However, there was a balance between discomfort and danger and the potential for accident and injury, and thus the decision to not proceed. So future research could examine the factors and pressures that influence these cost-benefit judgments and people's decisions to continue or to turn back in poor weather. When asked to list up to 5 types of risk in Antarctica, people mentioned risks that were related to physical injury, environmental, operational, psychological and social factors. Interviews were framed around weather decision and information use, so it's likely this did influence responses. Physical risks from weather and terrain were mentioned the most frequently, with people being concerned about falls or becoming lost due to poor visibility, either in fog or blizzards. The time to rescue, limited resources, delays, and the greater consequences when operating in Antarctica were also themes in people's concepts of risk. Psychosocial risks, that is, risks around with working and interacting with people, were frequently mentioned, indicating that these people risks were a key consideration of operating in Antarctica. People risks included the challenges of working with and managing new and experienced people, considering different risk sensitivities, priorities, physical capabilities, knowledge levels and team skills. Most importantly, when a lack of team cohesion or poor performance impacted people's ability to do their work or complete projects. So this would possibly disrupt an entire research season. When asked to rank the weather they had experienced in Antarctica from the most risky to the least, people rated different weather risks as the highest, second highest, etc. Rankings then varied according to people's experiences, their roles and activities, reflecting that perceived risk is individual to each person and their context. Overall, wind, particularly strong winds, followed by visibility and blizzards, were seen as the riskiest weathers. These weathers are also some of the most useful information for people's decision making. Blue sky days, calm, clear, warm conditions were seen as the lowest risk days. Different combinations, for example, wind and snow or wind and low temperature, were rated as riskier than those weathers individually. So we can draw on a broader understanding of how risk is perceived in Antarctica and theories of risk communication, decision-making and behaviour to improve hazard awareness, education, decision-making and safety in Antarctic environments. Our results show that people have different concern and ideas of what risk is in Antarctica. Current weather and environmental training, if it is received, can be generic and narrow, for example, focusing on cold injury or sunburn. People new to working and operating in Antarctica may not receive suitable training and may not have appropriate risk awareness or sensitivity to keep themselves safe, especially if they've not worked in polar environments previously. Varying deployment locations, activities and weather and climate regimes mean we are exposed to different hazards and levels of risk. Therefore, there is a need for distinct activity and location-based risk communication, training and information. People's safety in Antarctica may be increased through helping people to develop their situational awareness and knowledge of their local environment and an understanding of safe weather limits, also highlighting the importance of contingency planning. More research is needed, but social and people risks may be reduced by selecting, educating and supporting expeditioners to build effective and adaptable teams. And while risks around inexperience, unfamiliarity and team integration could be addressed through mentorship and opportunities for people to develop operational experience and skills in situ in Antarctica. Thank you very much.
Thank you, Vicki. Make a note of your questions. We'll head over to Lisa and her recorded presentation first, and then I hope there's a few minutes for questions then. Thank you.
Good day, everyone. My name is Lisa Kelley, and I am the Director of Operations and Government Affairs for the International Association of Antarctica Tour Operators, or IAATO. I'm sorry I cannot be there in person, but if there is a silver lining to COVID, it is that through technology, we can still contribute to important discussions like these, even at a distance. Today, I would like to give you a brief overview of IAATO operator activities, our priorities, and possible solutions for environmental forecasting. IAATO was founded in 1991 to advocate and promote the practice of safe and environmentally responsible private sector travel to the Antarctic. It is not a coincidence IAATO was formed the same year as the Environment Protocol, and it is important to note that IAATO does not promote tourism. Rather, we are advocating for the proper practice of bringing visitors to the ice. Initially, 7 operators came together with a mission to deliver safe, environmentally responsible private sector travel, as it was apparent there was a need for a more practical, day-to-day form of management and standard-setting procedures for non-governmental visitors. IAATO operators also recognized there was a need to set aside competitive practices and pool experience, especially in the areas of ship safety, ship scheduling, and environmental protection. In addition to its mission, IAATO has a vision too, that through self-management, Antarctic tourism is a sustainable and safe activity that causes no more than a minor or transitory impact on the environment and creates a core of ambassadors for the continued protection of Antarctica. IATO's current management structure involves 42 full operators, 13 provisional operators who will not be full members until their operations have been reviewed to make sure they meet IATO's high environmental and operational standards, and 50 associates, who consist of groups from ship agents to travel partners. The work of the organization, creating guidelines and putting forth proposals to further the mission, is done by a series of committees and working groups, which cover everything from field operations to education and outreach. All IATO operators work within the framework of the Antarctic Treaty System, and all activities are permitted or authorized by a national competent authority through the appropriate processes and development of environmental impact assessments. IATO's self-management has been successful, largely due to the unique political system that is the Antarctic Treaty, and the fact that whether ratified or not, all IATO operators are bound to follow all treaty resolutions, measures, and decisions. However, the driving force of IATO is the people involved. IATO members are genuinely passionate about Antarctica's future. 95% of Antarctic tourism takes place via vessel around the Antarctic Peninsula. IATO vessels range in size from small 8-passenger yachts to what one would consider the traditional cruise vessel of over 2,000 passengers. Although it is important to note that ships above 500 passengers cannot make landings in Antarctica. We do have a few ships which operate in the Ross Sea, and we are seeing more and more expeditions which are performing semi-circumnavigations, departing from a South American port and ending in New Zealand or Australia, and vice versa. Our expedition vessels also have a wide range of ice classes as detailed by the Polar Code. But the trend of newer vessels, which are now being launched, is a higher ice class, which is expanding the expedition range. Our deep field and air operator activities are wide-ranging, from SAR support for solo expeditions, to visits to the South Pole, to emperor penguin colony visitation, and support for the national Antarctic programs. All IATO operators, whether deep field, air, or vessel-based, follow the principle of self-sufficiency and not impacting national science and logistic programs. To be as self-sufficient as possible, it is important for operators to have as much relevant data as possible, particularly around ice and weather forecasting. For the next few slides, I want to focus on the top priorities for environmental forecasting, which have been identified by our operators. These priorities not only focus on the marine environment, but also the deep field. IATO has a running list of weather and ice information available to operators. As we know, wind, weather, and ice are extremely unpredictable, especially in the Antarctic. And while prediction technology has vastly improved since I first started on expeditions over 2 decades ago, weather and ice make or break the expeditions. There are still gaps and delays for operators to access this important information, particularly in real time. Vessel operators need the real-time data for their voyage planning, and deep field and air operators need appropriate weather data to plan their aircraft movements as well as overland vehicle transits. Specific to vessel operations, up-to-date ice charting is absolutely essential, and essential to have every day of the week. In the past, IATO has worked with the British Antarctic Survey to create Polaris, and also worked with our sister organization in the north, IAATO, and the Norwegian Ice Service to try and provide 7 days a week ice charting. While unfortunately this did not continue, we do collaborate and discuss ice charting concerns and needs with the International Ice Charting Working Group. And having daily access to updated ice charts has been on our wish list for a very long time. We know that for any product to be useful, it needs to have the appropriate information fed into it. IAATO operators feel very strongly about sharing the information for the good of Antarctica and all its stakeholders, but what is the best way for us to do so? Currently, one of the challenges of feeding into weather and ice data processing is the multitude of requests from stakeholders and the number of possible depositories for the information. IAATO as an organization, as well as our operators individually, receive many data requests from Antarctic stakeholders, specifically around environmental forecasting. It can be overwhelming and actually lead to a lack of data being shared. There are, of course, some automated systems for the collection of data, but real time is important. And IAATO operators know this and know that the real-time data is important for modeling. But of course, this needs to be delivered at the same time when there are a multitude of other operations actually happening on an expedition. Save operators creating a position on board for transmitting data to stakeholders, is there a way for a central depository to be created which could then be shared with the appropriate stakeholders? A good example of this type of depository is one that is being developed called SIGLAC-C, specifically around ice data. In this electronic model, operators can do the input of real-time information. It is then sent over a low bandwidth system and reaches a depository, where then multiple stakeholders who want this information for their own purposes can access it. We of course know there are challenges for product developers to create a depository and delivery system which suits all users, but a central area where this information can be collected would assist our operators in ease of data delivery and hopefully increase participation in crowdsourced information. Thank you all for listening to this presentation. I will be participating via Zoom in the panel discussion, but please feel free to reach out to me should you have any further questions. Thank you again and take care.
Thank you, Lisa. That was great. I realize that we're a bit against our lunchtime here, so I would suggest we keep Vicki's questions for the lunch break and afternoon tea break, seeing that she's here. And I would open the floor to a couple of questions for Lisa in particular, seeing we've got her online. Are there questions? If so, please, approach Irina there.
Thank you for your presentation. It's interesting to see the other side also, about Antarctic operations. Can you please specify more about what are the most important stakeholders that you have been working on? Any particular examples or,
Yep, hopefully you all can hear me. Yes, excellent, great. Thank you again, and again, sorry I can't be there with you in person. But as far as stakeholders, which just as an example, we are approached by at least 6 different stakeholders around ice charting. So those who are looking for the information from our vessels, and all would like the information about the ice that our operators are seeing in real time on a certain day, which will then be fed into a process for modeling. But the conundrum comes is that not only is it really difficult for an operator to even consider sending 6 different bits of information to a ice charting product developer, but also it's very difficult that they come in different form. Everybody wants it in different formats. So that also becomes a time-consuming project. it's certainly not, again, that we don't want to invest the time or the effort into delivering this information, because it is so important. It's just finding the best way to collaborate. And as my friend and colleague Karen said earlier, there really is a great opportunity for collaboration, but just one that works for all of the parties.
Thank you, Lisa. Is there another question for Lisa? Or do people want to leave for lunch? I realize, Lisa, I'm really sorry. We are up against the lunch. There's one more question. Yes, David.
Hello, Lisa. Thanks for your presentation. I was looking at the list of weather products that you listed on one of your slides. Are you familiar with the Antarctic Mesoscale Prediction System run by the National Science Foundation and located at NCAR?
No, if it is not on our list, then it's not been something that has been brought directly to our attention, but we would love to be able to expand that list for our operators to give them as many opportunities as possible to find the data they're looking for. So absolutely, we can add that to our running list.
Because that's run
bringing it up.
routinely twice a day for the Southern Ocean and Antarctica at pretty high resolution. So that would be good for most coastal applications, for example.
Wonderful. Thank you so much for bringing that up.
Thank you, David, and thank you, Lisa. So EMS, I mean, maybe Dave can send you the details on EMS. Yep, he's nodding, so you probably can expect an email. So thank you again for joining us online. Thank you, Vicki, for joining us here. Thank you, everyone, for your attention and for moving into the lunch break for us. Thank you.
Thank you. Take care.
Before everybody leaves the room, I have two quick announcements. So I just remind you that tonight we have the conference dinner. It's going to be in this room.